Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be studying area and parallelogram. Okay, let's start with a parallelogram that has one diagonal. Okay, this diagonal cuts this parallelogram into two congruent triangles. So we have here triangle ABC and triangle ABC. And these two triangles are congruent. To prove that, this side is equal to this side. This side is equal to this side. And since this is a common side, then that means we have here SSS congruence. So these two triangles are congruent. And since these are congruent, then that means the area of this triangle is equal to the area of this triangle. Okay, how about if there are two diagonals in a parallelogram? So these are the two diagonals in this parallelogram. When we draw these two diagonals, then we created four triangles. Okay, this triangle, this one, here, and this triangle. Okay, now, this triangle ABO, okay, triangle ABO is equal to triangle AOD. Okay, why did I say triangle ABO is equal to triangle AOD? If we are going to take a look at this one, triangle ABO and triangle AOD have the same base. So this is the same base. And they also have the same height. So even if the triangles are not exactly the same shape, if they have the same base and height, then those triangles are equal. Okay, we can actually think like this one. Okay, if this is one triangle and we have here another triangle, okay, since they have the same base and they have the same height, then these two triangles are equal. Okay. This triangle ABO is, we all know, equal to this triangle DOC. And since ABO is the same area with AOD, then that means it's also the same area with triangle BOC. So the area of this triangle, the area of this triangle, and this triangle are all the same. And if we will add these four areas, then that's the area for the whole parallelogram. Okay, for number 3, what about if there's a point or any point inside a parallelogram? So it's any point inside a parallelogram. And in this figure, the point is this point P. Okay, from the vertex to point P, let's draw a straight line. So here, this one, and this one. Okay, when we draw these four straight lines, then we created 1, 2, 3, 4 triangles. Okay, now, this triangle on top, APD, and this triangle BPC, the sum for these two triangles is half the area of this whole parallelogram. Or the sum of these two triangles is equal to the sum of these two triangles, the triangles on the left and triangles on the right. Okay, to prove that one, okay, if we are going to draw straight line here, and straight line or this vertical line here, okay, as you can see, we have here 1, 2, and this is third parallelogram, and now this is our fourth parallelogram. Okay, in this first parallelogram, we have here this diagonal line. So it means if this is, or this area is just equal to this area. So if this is 1, then this is also 1. Okay, how about here? We also have another parallelogram here. So this one, if this is 2, then this is also 2. They are equal in measures, or they are equal in areas. Okay, if this is 3, then this is also 3. And if this is 4, then this is also 4. So same areas, same areas, same areas, same areas. Okay, now, I mentioned a while ago that triangle AOD plus triangle BPC is equal to triangle APB, or the sum of triangle APB and triangle DPC. Okay, triangle DPC. Okay, to prove that one, look at this one, triangle APD. So triangle APD and triangle BPC. So it looks like this. So this is 1, 4, this is 2, 3. Okay, and for triangle APB and triangle DPC, APB is this triangle. And we have this one. So this is 1, 2, and 3, 4. So the area of these two triangles is equal to the area of these two triangles. So if we will add these areas together, then that's the area for this whole parallelogram. Okay, let's have another example by answering this concept check question. In parallelogram ABCD, point P lies inside the figure. So this is point P. If the shaded part is 26 square centimeters, meaning this red part and this red part, or this shaded part, is 26 square centimeters, then what is the area of the parallelogram? Okay, as I mentioned a while ago, okay, this triangle on this side, or on this left side, plus this right side is equal, if we are going to add the areas, the area of this triangle on the left side plus the area of this triangle on the right side, this is equal to the sum of the triangles on this top and this bottom triangle. So if these two triangles are 26 square centimeters, then that means this one plus this triangle is also 26 square centimeters. So what is the area of the parallelogram? So that would be 26 plus 26. So it means 52 square centimeters. Okay, now let's answer this simple question. In parallelogram ABCD, point O is the intersection point of the two diagonals. So this is point O. If the area of parallelogram ABCD is 52 square centimeters, so the whole parallelogram is 52 square centimeters, then what is the area of the shaded region? Okay, so this shaded region, or this triangle plus this triangle, is half the measure, or half the area of this whole parallelogram, because this triangle, the unshaded on top and the unshaded below, if we will add these, this measure or this area is also half the area of this parallelogram. So it means we have to divide 52 by 2. So that would be 26. So it's going to be 26 square centimeters. So that's the area of this shaded region. Okay, and for the last question, according to this one, okay, in parallelogram ABCD, point P lies inside the figure. So this is point P. If the area of triangle PAD, so we have here PAD is 9 square centimeters, and triangle PBC is 12 square centimeters. And what's the area of the parallelogram ABCD? Okay, this triangle plus this triangle on top and triangle here below, if we're going to add these two areas, then that's the area of this parallelogram, or half the area of this parallelogram. And this left and right side would also be the half the area of this parallelogram. So if we are going to add this together, then that's the total area for this parallelogram. So we have here 9 plus 12, then that's going to be 21. So 21 square centimeters for this on top and below triangle. It's asking for what's the area of this parallelogram. So we just have to add another 21 square centimeters, because this sum plus this one is the total area of this parallelogram. So this is now equal to 42 square centimeters, and this is the area for this whole parallelogram.